Hello ladies and gentlemen. 5.4 day 2 is just going to be a continuation of what we did in the last video. We're going to look at more radical equations and equations with fractions, exponents in them, but in this video we're going to involve more than just square roots. So to solve equations in this form, x to the m over n power equals k, the basic solution is going to be to take each side to the reciprocal of your exponents, okay, to the reciprocal power of the exponents. In this case, the reciprocal of m over n would be n over m. One thing we do want to watch out for is if the m value is even, so the denominator of the power you're taking each side to is even, then you must remember to use a plus or minus sign in your answers, and we're going to see why that is down here in example 1. Okay, so number 1, I have 3 times the quantity x plus 1 to the 2/3 power equals 12. Well, you have to envision that the 2/3 power is the same thing as having a cubed root, so this is really the radical part right here. Okay, so that means I need to isolate that by dividing both sides by 3, first of all. So when I do that, I get x plus 1 to the 2/3 power equals 4. From there, I'm going to take both sides to the reciprocal power based on of my exponent. So since I have a 2/3 exponent here, to cancel out that exponent, I need to take both sides of my equation to the 3/2 power. So here and here, that's going to cancel out my 2/3 and just leave me with x plus 1 on the left side. Okay, on the right side, 4 to the 3/2 power is the same thing as square root of 4 cubed, based on our definition of a radical exponent. And you also have to remember that for this problem, because the denominator of your exponents, okay, right here, the denominator of that exponent is even, that implies that you need to use a plus or minus sign over here on the right side. The reason being is a square root, whenever you take the square root of two sides of an equation, okay, you know you must use a plus minus sign. For instance, if I give you the equation x squared equals 25 and I told you to solve that, you'd have to take the square root on both sides, and I always told you guys you had to use a plus or minus sign to tell me that x is equal to both positive 5 and negative 5. Same thing here, okay? When you take something, when you raise something to a power and the denominator of that power is even, okay, it implies you have an even index, and so you have to use that plus or minus sign there. Okay, so just make sure you're watching out for that. Alright, let's simplify a little bit over here on the right side. So we have plus or minus, radical 4 is 2, and 2 cubed would be 8. So I get plus or minus 8 over here on the right side. Left side, I still have my x plus 1. And so x ends up being, if I subtract 1 from both sides, negative 1 plus or minus 8. Well, negative 1 plus 8 would be x equals positive 7. Negative 1 minus 8 would be x equals negative 9. So I have 2 potential answers here. I do need to check those for extraneous solutions. However, I'm going to use my calculator to do that. Okay, so going to my calculator, I'm going to type in my original equation. So we have 3 times the quantity, okay, x plus 1, so I'm going to test 7 first, so this would be 7 plus 1 raised to the 2/3 power equals 12, and so we'll check that, and we see that that is a true statement. Okay, now I can go up and I can copy that equation. And now scroll down and paste it. And instead of 7, now I want to test negative 9. So I'll see if that works, and that one is also true, meaning that both of those solutions are, in fact, actual solutions. So my solutions to this equation are 7 and negative 9. Okay, number 2, we have 3 times the 5th root of x plus 1 cubed plus 1 equals 25. Okay, so the first thing I'm going to do is I'm going to isolate my radical. To do that, I'm going to have to subtract 1 from both sides. That's going to give me 3 times the 5th root of x plus 1 quantity cubed equals 24. And then I'll divide both sides by 3. And when I divide both sides by 3, I end up getting an 8 on the right side. I'm going to rewrite the left side now, okay, as a fraction exponent. So the 5th root of x plus 1 cubed is the same thing as x plus 1 to the 3/5 power. Okay, so all I did there was I rewrote it. I haven't taken anything, I haven't taken both sides to a power yet. I just rewrote my radical. Now that I've rewritten that, it's easier to see what power I need to take both sides to. I need to take both sides to the 5/3 power to cancel out this 3/5 here. So this just gives me x plus 1 equals, let's see, 8 to the 5/3 power would be the same thing as the cubed root of 8 to the 5th power. Notice I'm not taking an even root, okay, of this side here, so I don't need a plus or minus sign, okay? It's only when your denominator here is even that you need a plus minus. The cubed root of 8 is 2, and 2 to the 5th power is 32. So really I have a 32 over here. X plus 1 equals 32, meaning x is equal to 31. So only one potential answer for this one. I do need to check it though to make sure it's not extraneous. So I have 3 times the 5th root of x plus 1 quantity cubed. Oops, and instead of an x, I should probably plug in the number I want. So I want to test 31. There we go. And I'm setting that equal to 24. So let's see if that is true. Oh, I need a plus 1 there. All right, make sure that's the right equation. There we go. I'm setting that equal to I'm setting that equal to 25. There we go. Looking at the wrong line. 3 times the 5th root of 31 plus 1 cubed plus 1 equals 25. Let's see if that's true. Yes, it is. Okay, so 31 is your answer here. All right, I need some more coffee this morning. 2 times the quantity x plus 3 to the 2/3 is equal to 8. Number 3, let's have you pause the video, try that one on your own, and then once you do that, click play to check and see if you got it right. Also, don't forget to check for your extraneous solutions on your calculator. Do that now, please. Okay, so if you did that correctly, you should have ended up with 5 and negative 11 as your two solutions. Okay, you can see my work up here. When you check 5 and negative 11, they both come out correctly, so you have two solutions for this problem, 5 and negative 11. Okay, moving on to number 4. We have 1/7 times the quantity x plus 9 to the 3/2 power equals 49. Okay, so same sort of thing as the last few. I need to isolate my x plus 9 to the 3/2 first, so that means I need to multiply both sides by 7 to get rid of this 1/7 here. So you get x plus 9 to the 3/2 power equals 49 times 7 is 343. And now I need to take both sides of my equation to the 2/3 power. So that's going to give me x plus 9 equals cubed root of 343 squared. Okay, the cubed root of 343 we know is 7, and then 7 squared is 49. So right side you get 49. X plus 9 equals 49. That means x is going to be equal to 40. Let's go to our calculator and check. So we have 1/7 times the quantity 40 plus 9 to the 3/2 power. And that's supposed to be equal to 49. Let's see if it is. Very good. So one solution to this one, 40 would be that solution. Okay, last one. We have radical 3x plus 1 minus radical x plus 1 equals 2. Yes, there is a reason there is a lot of space. Be sure you write small for this one here. It doesn't look bad, but there's going to be a lot of work for this one, so just make sure you write small enough to fit it all there. Okay, just like for the last lesson, I told you guys if you have two radicals in a problem, make sure you isolate the more complicated looking one first. 3x plus 1 is just a little bit more complicated looking than x plus 1, so I'm going to isolate this puppy here first. So I'm going to add radical x plus 1 to both sides, which gives me radical 3x plus 1 equals radical x plus 1 plus 2. Okay, so now I need to get rid of this first radical on the left side by squaring both sides. So square here and square here. On the left side, it's just 3x plus 1. On the right side, let's work that out and see what we get. So radical x plus 1 plus 2 times itself. When we FOIL that, we end up getting x plus 1, no radical, plus 2 radical x plus 1, plus 2 radical x plus 1 again, plus 4. So if I simplify that, I end up getting x. I have a plus 1 and a plus 4, so I can combine those and say that's a plus 5 at the very end. And then my middle part, I have 2 radical x plus 1 and 2 radical x plus 1. Combine those, I get 4 radical x plus 1. So in the middle we have plus 4 radical x plus 1. Okay, so now I still have a radical in my problem. That means I need to isolate this second radical right here. So I need to subtract x and subtract 5 from both sides, which gives me 2x minus 4 equals 4 radical x plus 1. And now I need to get rid of this radical here by squaring both sides. Again, you could divide both sides by 4. I'm not going to for this one simply because if I divide 2 by 4, I get my fraction of 1/2, and I don't like dealing with fractions when I don't have to, so I'm not going to. Just going to square both sides here. The right side, we get 16 times the quantity x plus 1. Be careful with your parentheses. You've got to put the 16 outside of parentheses, okay, because we're going to have to distribute that 16 in a second. So 4 squared is 16. Quantity x plus 1 squared is just x plus 1, but make sure you put in those parentheses there. 2x minus 4 quantity squared will give you 4x squared minus 16x plus 16. Now I go through and I distribute on the right side, and I get 16x plus 6. And so now you can see again we have a quadratic, and we want to set that equal to 0. So I'm going to subtract 16x and 16 from both sides. Okay, the 16s cancel, 16 and negative 16, but the 16x's are both negative, so that combines to negative 32x. So I end up getting 4x squared minus 32x equals 0. I can factor a 4x out of this binomial here, so I get 4x times the quantity x minus 8 equals 0. And now I get two potential answers to this. X is either equal to 0 or x is equal to 8, which I must now go to my calculator and check. So starting with 0, so we have the square root of 3x plus 1, so that'd be 3 times 0 plus 1, minus the square root of x plus 1, so square root of 0 plus 1, equals 2. And if we do that, we get a false statement. So that means that 0 is extraneous, and we're not going to include it in our final answer. Okay, now let's try positive 8. I'm going to go ahead and go up and just control copy that equation so I don't have to type it all in again. And then control paste down here. Okay, instead of 0, I'm going to plug in an 8. So 3 times 8 there. And 8 plus 1 there. If I try 8, I get a true statement. So 8 actually works, which means for this problem here, I have one solution, and that would be x equals 8. Alright, so hopefully that was nothing you can't handle. Again, questions, feel free to shoot me an email on those before class, or jot them down and ask them to me the next time you see me. Until that point in time, as always, have a nice day. You're all wonderful people. Take care.